Alright guys, welcome back to Year 7 Maths with Mr. Rowe, and it is 12 past 10 p.m. right now, and that's how excited I am about this maths. So hopefully you can be excited with me. I just love this angles unit, or geometry unit, whatever you want to call it. Feel free to watch in fast mode to hear my voice go faster, to get through it faster, to skip through parts to whatever you need to know if you don't know parts, and we're just going to get into it. So here, it's quite simple. A point is a point. It's labeled with a letter. That's P, point. A line, not to be confused with a line segment down the bottom, but a line is can be named using 2 points. So it's A and B is here, but it goes on forever. You can see the arrows. These lines, they go on forever. So it's not just that line. That's what the arrows mean. A plane is a flat surface that extends indefinitely as well. So these arrows show that these sections go on forever. A collinear line is a line that has all these points lie on a single line. They're called collinear. So it's not a collinear line really, it's the collinear points. A, B, C are collinear because they all go in the same straight line. And more than two lines that meet at the same intersection point are called concurrent. So you see this here. So any of these lines, well, that's not a perfect line, but if they all went through the same point here, to make that bigger, concurrent lines. And then a line segment is like a line, but it's just part of it has fixed endpoints. You see there's no arrows there. It's a line segment. You just have to know these. There's no real scientific knowledge. You just have to know these. A ray is much like a line, but it has one endpoint and then it goes on forever in another way. And it's again named by its points there, A and B. And then here, when two rays or lines meet, an angle is formed at the intersection called the vertex. So the vertex is like a corner, I suppose. And you use those vertexes are an important thing in angles because you can see this now makes an angle. You've got an arm and an arm, which is really an array. Two rays put together creates a vertex and an angle. And then the angle is named by its 3 points. So ABC or CBA. Now, the important thing here is that B is in the middle because it's the vertex. It must be in the middle. The other important thing is that you show the angle symbol first because there will be triangles and other things later. So you must have that there to label it with the angle. So, for example, this angle here, where it says that is BOC or COB, because, and with the angle sign first, because again, the vertex must be in the middle. This one here, or rather this one here, it's angle BAC or CAB, again with the angle symbol, because again, the vertex is in the middle. This is EAEB or BEA, the angle. This is AOB or BOA, and you see the way I'm drawing it there. Actually, I need to rub that out. My apologies, I didn't see that went over. That would just be that angle, but you see here it goes over both of them. So it's actually AOC or COA. I'm not editing that out. You'd be right. So that's it for 2A. That was pretty basic. 2B now. You see, and you should know this from a long time ago, acute angles. I taught it in year 4. Acute angles between 0 and 90. They are small, they are acute. Right angles, perpendicular lines, complete opposite lines create 90 degrees, always symbolized by this, not always, but usually symbolized by this square inside the angle near the vertex. Obtuse, between 90 and 180. So 90 is not it, 180 is not it, but it's really 91 to 179. Anything in those bracket is obtuse. The straight angle is a straight line, it's 180 degrees. A reflex angle is anything between 180 and 360, or really 181 and 359, because if it's 180, it's not a reflex, it's a straight. And then a revolution is a 360, complete way around, perfect circle. Again, you just have to know these. You can't, there's no trick to this, you just got to know it. Now here we've got a protractor, and it can be, this is the way you measure on a protractor. So there's the angle AOB here, or BOA. And well, we'll go down here and check this out because they're a bit bigger on this one. So here we got an angle, and some of you get confused like, oh, do I measure the outside or do I go from the inside? Well, you just look at whatever the line is on 0. So here, the straight line or flat line is on 0 in the middle, in the inside. Therefore, you read the number on the inside. So that would be then 50 degrees. Over here, you've got the 0 on the outside, and therefore, if you go around to here, on the outside between 140 and 150, it's 145 there as well. Here upside down, again the 0 is on the outside. So you go over here, that's between the 50 and 60, so that's 55. And I think you get the point. Always check where the 0 is and go from there. That way you know whether it's the outside or the inside. I'll do this one because it's a reflex. Over here, you can see it's a reflex because the arc is on the outside, not inside like that. And you notice it's on the 0 on the inside. But how do I do 360? I don't know, Mr. O. Well, I'm going to tell you because I'm that kind. What you really need to do here, because it's this you're measuring, not the inside, but a revolution is 360. So one of the best ways, there's two ways to do it. One, you can just do 360 minus whatever this angle is here. So you see 0 is on the inside, so that's 110. So 360 minus 110 will give us 250. Or you could say, well, that's a straight angle, so that part there is 180. So what's this little part in here? Well, that would be the 0 on the outside. That would go up to 70. So 180 plus 70 is 250. Whatever works for you, really. Now, I can't measure a protractor on this. What was my plan here? I'm not sure what my plan was to use a protractor to measure that. But I suppose the point is you have to put the 0 point right there in the middle. Sorry, put the middle point on the vertex and then have a 0 on that line. And then you just measure up like that. Now I'll draw one here. If they say use a protractor to draw one, what you do, if you had to put a dot here in the middle on your paper, then you place the protractor on top of it so it looks like what it looks like now on my screen. And then you say, well, there's 0, or the other way, whichever way you want to do it. But there's 0 in line. You can't obviously just draw. I could draw it here. You can't because you can't draw through your protractor. There's 0, so I draw a line there that's in line with that, a dot there rather. And then let's say you want to draw 70 degrees, well that's here, but you can't draw there. So to draw there, then you take your protractor away, put the straight edge on it, which I'm not going to do on the computer, put the straight edge on it and draw an angle in a perfect straight line. Again, I haven't done that. And then that would be 70 degrees. That's how you draw an angle, okay? If you want to do it from the other end, just do that. Put a dot here of 0 and then whatever, here for 100 and draw it like that, whatever. But that's how you use a protractor to draw an angle. If you want to draw a reflex angle, you have to do what we did before, and that is draw the smaller part of the angle. So if it's like 300-degree reflex angle, just draw an angle that is 60 degrees, because then those two would make up angles in revolution, which we'll talk about later. And then you just put the circle thing on the outside, not on the inside, because then that means the opposite of 60. Anywho, on to 2C now. Adjacent angles are side by side and share a vertex and an arm. So here's an arm that they share, and they share the vertex of O. Therefore, that angle inside is BOC, and that angle is AOB. Again, with the angle symbol. That's adjacent angles. Okay, they're important because when you get two things such as this, those angles are adjacent. They share an arm and they share a vertex. And these are complementary. They sum to a right angle. Okay, this is so important that you know. Complementary versus supplementary we'll talk about. So A and B together are 90. Because that way, if you know A, you can figure out B. If you know B, you can figure out A. And supplementary lines are very similar, except they add to 180. So, and that's even probably more important because you have straight lines all over the place. So whatever the angle leaves behind is a straight line. So A and B together equal 180. Angles in revolution, we just talked about that. That's the sum to 360. Much like complementary, is 90, supplementary is 180. If you have trouble remembering them, the tiny thing I can think of is that complementary starts with K or C, and supplementary starts with S. S is later in the alphabet, therefore it's a bigger angle. Too bad it doesn't work with revolution. Revolution is before S, so it doesn't work. But complementary C is 90, smaller, earlier in the alphabet. S, supplementary is later in the alphabet and a bigger number, 180. Angles in revolution sum to 360. We've been over that. So you got a reflex angle on the back, an obtuse angle on the middle. It can be anything though. They don't have to be obtuse, but or even reflex. They could have two straight angles would add up to be angles in revolution. Vertically opposite. So here we have concurrent lines. They run in across the same point. And the important thing here is that angles that are vertically opposite technically don't have to be vertical like that. A and A are horizontally opposite, but that's not a thing. Vertically opposite, they are equal. Okay, so B and B are equal here, and A are equal here. So if you knew 1A, you could figure out actually everything, because you could have A and then take that away from 360 and then divide that by 2 because there's two B's, but that's whatever. And then perpendicular lines are concurrent lines that meet at right angles. You see how that's 90 degrees, that's 90 degrees, that's 90 degrees, that's 90 degrees, whatever. All right, name the angle which is complementary to ABC. Well, that just means what adds up to, these are all right angles, so it's really easy, but what adds up to 90? So that's ABC there. So obviously DBA. I'm not going to do the rest. That's fine. Vertically opposite to SOT. Well, here's SOT. So the opposite of that, think of it, if you're struggling, think of it like an arrow. See that? But that's like big arms of an arrow, or pointers of an arrow, and there's a tail pointing to the other angle, which is here, which would be U. I think that's a no. I've drawn so much over it. UOV or VOU. Okay, and here again was SOT. SOT is there, even though the O's on the other side. Still doesn't matter. SOT again. It's like a big pointer, which means mon or nom. Nom 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 is the angle there. Supplementary, remember, probably the most important, although they're all important. AFS. AFS is that angle, so obviously the other supplementary is MFS. They add up to 180. Remember, supplementary 180. So without a protractor, this is how it works. Find the value of A. Well, here's A. They add up to 90 because they're complementary. So 90 minus, you should write this in the exam, 90 minus 30 equals 60. So A equals 60 degrees. Put the degree sign in. Much the same here. 90 minus 21 equals, or A equals, you can have A equals here too. It's late. I want to go with 69 degrees, not 69 purple elephants. So I'm not going to do more complementaries. You should have that by then. That's how they're working out. Here's supplementary. So it's 180 minus 45 means A equals, you can have it here, A equals 135 degrees. Supplementary again here. This is 180 minus 39 equals 141 degrees. So A equals that, and I'm not going to do any more supplementary here. There's not really any addition or anything to be done. They're just vertically opposite, so A equals 115 degrees. That's vertically opposite, that's vertically opposite. Okay, this is angles in revolution now, so that would be 360 minus 120 equals 240 degrees. So A equals 240 degrees. This is also angles in revolution, but it would be 360 minus 90 because that's the right angle. And this too, 360 minus 220. So two angles that are supplementary to AOB. Well, look at it. That's a straight line. So that angle there, COB, is supplementary to that one. And then that angle here, that's a straight line. So that's DOA. That angle in there, that's also supplementary because there's a straight line there and there's a straight line there. Supplementary. Add up to 180. Remember it. Without a protractor, remember these. This is just the same thing again, but bigger. So here we've got 90 degrees as a right angle, and then 90 minus 30 equals 30 degrees. So A equals 30 degrees. Here is 180 minus 65, excuse my writing on this laptop, minus 40. You can put that in your calculator. 75 degrees. Feel free to correct me if I get these wrong. This is 360 minus 100 minus 110 minus 90. If you want to, you can like add them up and then go 360 minus that, but I think this is fine. You just put it all in your calculator and it'll come out with the right answer anyway. Equals 60 degrees. And I'm not using a calculator, by the way. That's how awesome I am. You might say, Mr. O, this is getting too complicated. But let's do this one here. Like that's 45, that's 90. And how do we know what that is? Well, guess what? 45, 90, and that all equal, they have to equal 180, which means that also has to be 45, because it's a straight line. And then, because that's a right angle, then that also has to be a right angle, because it's the same, like it's a perpendicular line, so the bottom has to be the same as the top. It creates two right angles when you have perpendicular lines. So then, if that's 90, that means that's also 45. So you got 45, 45, 45, and 90, which means then you just do 360 minus 135, which is, by the way, is the addition of the 345s, minus 90, and you add that up, and you should come up with 135. Now, I'm realizing I've made some level of error here, because another option is that you just forget about this perpendicular line. Let me rub it out so I can go back and show you when it's a clean slate. Forget about this perpendicular line, and then what you get, if I'm not mistaken, is you get that's vertically opposite to that, and that's vertically opposite to that. So then those two would add up. So then you'd say, well, that's 90 and 45 together. So then A must be 90 and 45 together. The other way to do it as well is to realize that this is a right angle, and 45 and 45 make a right angle, and then this 45 and A are supplementary because they're from the straight line. I've talked about this too long, but there's a good way. I'm just showing you there's many ways to victory here. So the 135 and 45 would equal that, because some of these more complex ones confuse you. All right, here, how do you figure out A? It's just 90 divided by 3, because all A's are equal, so 3 lots of A. Here, that's 180 divided by 3. There's 3 A's there. That equals 60. Here would be 360 divided by 6, because there's 6 A's. You just work that out. Here, A plus 10, A minus 10. This part here is going to freak some of you out. Well, guess what? Plus 10 and minus 10, they equal out. So if you forget about them, all it really is 90 divided by 2. Here is 180 divided by 5. Again, here, plus 60 minus 60, they're equal. Doesn't matter. Just means just how they're balancing them up with A. So it's really just 360 divided by 2. All right, I don't know how far we're into this, but let's keep going. We're on the last one now, 2D, transversal lines, okay? This is probably where some of you are going to come unstuck. This, we don't like this, okay? This doesn't really, you won't see that really in maths because they don't help you any. You can't figure out angles on that, so what's the point in doing it? You have to measure those ones. But a transversal line is just a line going across two other lines, usually parallel. Like this. This is what we see in maths all the time. This is everywhere. We'll talk about it. Transversal line crossing two lines creates some angles. Some of the angles are corresponding angles. So, see, that's not a corresponding angle, so this doesn't help us again. But this one, corresponding angles. Now, they are equal. Now, some of you had trouble figuring out corresponding lines, but the fact of the matter is, or angles rather, not lines, it's the only other angles in all these. If you look at all these angles, there, you'll see there's only two that have the arms going the exact same way. You can use your hands if you're freaking out. there, and there. That's the angles of both of them. That's the only one that has the one arm going up and one arm going straight to the right. There's the only one. So therefore those angles are the exact same. Because these are parallel, this line cuts at the exact same place each way. Corresponding angles, they are equal. Again, they have the same thing. They correspond. They're the same. So if you need to visualize by putting your hands together in the same thing and moving around to find it, that's corresponding. Alternate angles are just the opposite. Now, opposite diagonally. See, there's no other opposite diagonally. You can opposite diagonally that way. That's not opposite diagonally. That's not opposite. Now that's just going down. That's vertically opposite, so you know that's not right. Because it's going across a point. So it's just jumping over the line and up, or jumping over the line and down. So like here, jumping over the line and down. Not vertically opposite. Not that. That's supplementary. Not down here, because that's co-interior, which we'll get to. Just jumping over the line and diagonally. Over the transversal line, I should say. Co-interior angles are like inside. They're like a little family living in a house. All right, look, I'll draw a house for you even. Hey, they're in a house. That's the, yeah. So this is an error, by the way. That should not be an X. That should be, oh, it is an X actually, sorry, because their dots mean they're the same. These are not the same. They add up, they're supplementary. They add up to 180. Okay, so they're inside together. It's just the next angle that you don't cross a line to get to. So you can't be that one, you cross a line. Can't be that one, you got to cross a line. Can't be that one, you cross a line. You can't be that one, you cross a line. Co-interior, they're together. They're co-inhabitants. They live together. All right. So, and they're supplementary because they add up to 180. Remember that. Again, you just have to remember this stuff. You can't figure it out at the time. All right, parallel lines are marked with arrows. So if there's two arrows there and then you had another set, you know that because they got one arrows, they match up. Okay. So they match up with the same type of arrows. If a transversal line crosses two parallels, then again, we already talked about corresponding equal, alternate equal, co-interior angles are supplementary. That's the important thing here. All right, so let's do some practice on this. Corresponding to ABE, this is this angle here. Now, what's the only one that has the same legs? It's this one here. So you see again, they've got arms going that way, and HED, which is the angle name, they also has the angles going that way. It looks the same. Alternate to ABE is, remember, across and down or up or across, whatever. Goes across and there. So that is FEB, Feb. Okay, co-interior, and I better rub some of this stuff out. Co-interior to EBA, remember living together, is DEB. DEB, remember house, look, they live together. That's the closest one that doesn't cross a line. Vertically opposite to EBA or ABE, again, it's like an arrow pointing, is this one here, GBC or CBG. Okay, remember to draw your angle symbols. So let's do these things in practicality. So find A, it's 130. They're corresponding. They have the same angle. 130. Here, corresponding. Look, same angle. They're the only ones that have the arms the same. So that A is 70. Here, alternate, across and diagonal. So A, that's also equal alternate, 110. Okay. Here, alternate, 120. Here, vertically opposite, 130. Because they're all equal. The only thing that's not equal is co-interior and supplementary, but we're not talking about that when it comes to parallel lines, not so much. Vertically opposite, 67. Co-interior, 115. Co-interior, sorry, my bad. They are co-interior, it's not 115. Co-interior, 65, because 115. Now, you don't know how to figure that out. You should working out should look like this. 180 minus 115 equals 65 degrees. So A equals 65 degrees. Here, 180 minus 62 leaves you with 118. These are corresponding. Look, they have the same angle. So A is 100 degrees. Right, here's where it gets fun. This is what gets me excited. these, you look at these, some of you are like, I'm freaking out, I don't get it. Well, guess what? If you extend this out and you continue the transversal, oh, look, magically we have those other lines. And so these are just, look, they jump across and diagonal. So A is their alternate, so that's A is 35. Same thing here, look, draw it out. Oh, look, that's also alternate, so that's also 41 degrees. Yeah, look, a different one, but guess, look again. Oh, it's magic. So they're living together in a house. It's co-interior, so 180 minus 70 is 110. Here, look, extend it out. Oh, co-interior, 150 and 30 is equal to 80. Well, look at this. Oh, corresponding, look, they have the same angle. So that's 60, they're equal. Here, extend it out, doesn't matter. Look, they're corresponding, they have the same angle. Same arms on parallel lines. Yeah, same deal. Look, boom, 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 boom. This is just two sets. Here's its own one over here. Here's another one over here. You've got two sets. So if we do that, you can see these are co-interior. They're living in a house. So 115 plus 65 is here. Again, two sets again. Look, there's a set over here, and there's a set over here. They have the same thing. Okay, there's the one line crossing two lines. They're just two lots of it. Here, line, line, and again, two lots of it. There's a set of all alternate and corresponding and vertically opposite. And then here's another one over here. So then these are corresponding. So that's 62. Yeah, I could go on. What's this one? This is different. Just ignore the circle part. Look, haha, we've made more alternate. 42. Here. It's just two again. Look, there's a set. And there's a set. They're a bit combined there, but they don't care about that. They just care about the fact that, whoop, that's a bad line. Care about the fact that when you draw that out, oh look, they're just alternate, so they're the same. What do we got here? Oh, these are complex. Find the angles in these diagram. Angle A. All right, so this one here. So they want you to figure out this one, because they're corresponding. So look at that. Boom. And you draw that out. That one, same angle as that one. Look. Dung, 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 dung. They look the same. How do you figure it out? Well, these are angles in revolution. This one here is DEB is because, look at that. So 360 minus 300 is 60. So then that's corresponding to that. And that equals 60. Here, that's not corresponding. So how do you figure it out? Well, this is looks like, because if you don't understand, look, that's like that. I almost thought it was for a second. And that's like that. They don't look the same. 65. Well, A, you could say this, you could do it multiple ways. You could say that's corresponding to that, so that's 65. And then that and A are supplementary, so 180 minus 65 would equal 115, or you could say, well, it's actually a worse way to do it, but you could say the same thing here. They're supplementary, so then that's 115, and then they're corresponding to A, so that's 115. I don't know. You can make your choice. The first way I showed you is probably better. What have we got over here? All right, well, I suppose because they're three, they all create, look at this. That creates the same angle, that, the same angle, that, the same angle. So whatever this is, this really means that that is 57, because they're all corresponding. And it's 57 and A are supplementary, so 180 minus 57 equals A. These look complicated, but they're not. All right, what do we got over here? You just got to take a second to look at it. So you draw your lines out. Ah, they're just co-interior. If you look at it, so A and 62 sheet need a supplementary, or like because they're co-interior, they add up to 180. So you just need to work that 180 minus 62. Here, what have we got here? Oh yeah, 40 degrees, and that supplementary. Alternate. So that's 40. 40, 80 is 120. 120. What do you need to get to 120 to get to 180? Because remember, all these are on a straight line. It's 60 degrees. but you need to do some working out about minuses and stuff. You don't have to work out for alternate, you just say it's alternate. You don't need to do anything about that. And last one, again, you can just fast forward if there's too much of this anyway. Beauty of YouTube. They want you to know that angle and that angle are alternate. If you cut that, you just got to ignore that angle because it creates its own set. That angle and that angle are alternate, so that's 25. So that's 25. And then the angles in revolution with this one here. So then 360 minus 25. And then you got your answer. 335 is the angle, is the revolution angle there. Oh, look, we've done. Man, I really enjoyed that. I don't think you probably did, but I hope you did. Done before we know it. Now it's 10:42, so that's what, about a half an hour video. But hopefully it's thorough. If it wasn't too quick, you can always slow it down as well if you want to go over it again. And I hope you do well in your exam and you learn something.